Hi, welcome back. I'm Professor Ridge, and this is a lesson for 2.1 graphs. The first thing is talk about the coordinate system. So we know that we place a horizontal axis. We call that the x-axis. Vertical axis is the y-axis. Okay. This is also called the Cartesian plane, xy axis. Um, so basically once I set this vertical axis down, horizontal axis, it's just for a frame of reference. So I can, based on this point right here, that's where everything starts counting from, so we call it the origin. And now I can describe the relative position of any point on this surface relative to that origin. And the way we do it is the x-axis is just like the real number line. Going to the right is positive. Going to the left is negative. And then the vertical axis, starting from the origin, going up is positive. Down is negative. Okay. And also the x and y axis splits the plane up into four distinct quadrants, as we call them, four distinct regions. And then we count them in counterclockwise fashion. So this is quadrant 1 in the positive, positive. Quadrant 2. Quadrant 3. And it's typical that we use Roman numerals when we talk about quadrants. Okay. So this one, now again, we know, just review real quick, ordered pair. It's called an ordered pair because the order matters. X is first, Y is second. The first coordinate tells you the side-to-side movement relative to the origin, and the Y tells you the vertical component relative to the origin. So if I wanted to plot the point 3, 2, I would start at the origin, go to the right 3, and then up 2. So this would be the point 3, 2. And again, to be in quadrant 1, you'd have to go to the right and up, so that's plus plus. Positive 3, positive 2 would be quadrant 1, and anything else in this quadrant. To be in quadrant 2, you'd have to go left, so your x coordinate would be negative, and then up, so your y coordinate would be positive. Quadrant 3, you'd be left, so negative, down, negative. Be in quadrant 4, it'd be to the right, so that's positive, and then down, negative. Okay, so that's the four quadrants. Let's practice plotting a few points here. Plot. Just mix them up. A is 3, 4. B is negative 2, 1. C is negative 2, 0. D, 3, negative 5. And E, 0, negative 2. Okay, so this is the x, y. Remember, it's always x first, y second. So 3, 4. You start at 0, 0. Going right is positive. So 1, 2, 3. Going up, 1, 2, 3, 4. Put a dot there. That's point A. Okay, then B is -2, 1. Where's B? C is -2, 0. So that's C. D would be 3, -5. Now, two ways to do this. You can think of it. You can start, the first number tells you left and right. So if it's positive, you go to the right. If it's negative, you go to the left. The second number tells you up and down. So positive, you go up. Negative, you go down. So for 3, 5, 3, -5 would be right here. So that's one way to do it. You can count it. 1, 2, 3, and then then -5. 1, 2, 3, 4, 5. The other way to do it is you can go to 3 on the X. You can go to -5 on the Y, and where those two lines meet, that would be the point 3 for X, -5, -5 for Y. So where those two lines meet, that would be the point 3, -5. So that's the alternate way to do it. Which for if I wanted to plot, say 147, 865, I'm not going to count 1, 2, 3, 4, 5 to 147. I'm just going to go along to the x-axis to where 147 is, go to the y where 865 is, and then where those would meet, that's where that point would be. Okay. All right, so that's plotting. Now let's do it the other way. Identify or name the quadrant of each point. Name the coordinates of each point. So we'll go the other way. So let's say this one was A. Just label everything for you. Okay. All right, so A, so what's A? So again, remember it's X, Y. So A would be -4, +4. How about B? B would be 3 for X. X is 3, and Y would be 1. Let's see, what's Z? And be careful, right? This is, to get here, you're going side to side 0 and then down 4. So it's 0, -4. And what would D be? So D would be -4, -2. All right. All right, so now name the quadrant of each point. So if I had, this is number 14 from the exercise set in the book. Now you don't have to plot this, you just have to think, all right, -6, so if we go back up to this picture, -6 is going to the left and -5 is going down, so we're here in quadrant 4, negative, negative. So that's quadrant 4. So if I did If I did number 20, that's interesting. 3/4, -1/5. So again, we don't have to plot it. We just have to know, okay, I'm going, x is positive, so I'm going to the right. And then y is negative, so I'm going down. That one's also, oh, I messed up, didn't I? Negative is to the left. Negative, that's quadrant 3. I can't read my writing. So let's back up here. This would be quadrant 3. Sorry. And then this one going to, so again, if I'm going to the right and then down, that's quadrant 4. So you don't necessarily have to graph it, you just think about it, right? So I'm going, for number 20, I'm going to the right and then down, so that'd be quadrant 4. And remember, it's quadrant 1, 2, 3, 4. You start positive, positive, go counterclockwise. All right, that's quadrant 4. Now, determine if it's a solution to the given equation. So what does it mean to be a solution to an equation in general? And hopefully you're recalling that a solution to an equation is the replacement value of the variable, or variables in this case, that when you substitute it in, it makes the statement true. So here they want you to determine if this is a solution to that equation. Okay, so what we're going to do is we're going to put 1 in for x. So remember, it's alphabetical order unless you're told otherwise. That's another reason it's called an ordered pair. And again, the order matters, right? This first coordinate will always be for x. Second coordinate will be for y, unless we told otherwise. So x is 1. Plug it in. So really what this question is asking is, if you plug these numbers in for the x and for the y, does this make a true statement? Is 4 equal to 5 times 1 minus 1? And so you do the math, you do them separately. So 5 times 1 is 5, minus 1 is 4. 4 equals 4. So yes. 1, 4 is a solution. Okay, so it's just a yes, no answer. So how about number 30? We got 4, -3, 2x minus y equals 11. Okay, so again, we're going to put 4 in for x, -3 for y. We're asking this question, is 2 times 4 minus a -3 equal to 11? Yes or no? So we do the math. 8 plus 3 is 11. 11 equals 11. So yes, 4, -3 is a solution. How about 34? 3, 2. Y equals x cubed minus 5. So again, the 3 is x, 2 is the y. We're asking this question, is 2 equal to 3 cubed minus 5? So 3 times 3 is 27. minus 5, which is 30, no, 22, which is not equal to 2. So no. Okay. All right. Now, graphing. Okay, so graphing. One thing I want you to remember or note is a graph is a picture of the solution set. So if I ask you to graph y equals x plus 2, I'm actually asking you to draw a picture of the solution set for this equation. So so the most basic technique for graphing so if you have no idea what the graph looks like, this is your fallback, is you're going to make a table. Pick numbers for x and plug in. Okay. So you're going to make a table, plug it into the equation, solve it for y. And plot the point. Then you're going to repeat and repeat and repeat and repeat. So I'm going to pick a number for x, 0. Plug it in to the equation. 0 plus 2 is equal to 2. So I'm going to plot the point 0, 2. I'm going to repeat that. Pick the number for x, plug it into the equation, solve it for y, plot that point, and keep doing it until I know what it is. Now, if it's a linear equation like this is, I only need to plot 2 points. 2 points determine exactly one line. But if it's a nonlinear equation, meaning it doesn't make a line, you have to plot a whole bunch of points. So I'm going to pick 2. 2 plus 2 is 4. Plug it in, plot it. Okay, so 3 is enough. So if I plot the points, 0, 2, 1, 3, 2, 4, then I can draw a line through it since I know the linear equation. So how do I know that? I have 2 variables, x and y, or even if I have 1 variable, but I'm working in a 2-dimensional space on a plane, and none of the variables have any exponents to it, and there's no absolute values. That's going to give me a linear equation. So a linear equation, we'll talk more about this later in the chapter here, or actually next section, has form y equals mx plus b, ax plus by equals c. So this is slope-intercept form, standard form. And the thing that makes it linear is both x and y, they're just degree 1. They're just to the first power. That's what makes it linear. Now if you had an x squared, a square root, absolute value, it wouldn't be a linear equation. So how do you graph something that's not linear? Well, you can use this basic technique. If you know it's a line, you have the slope-intercept form, which is a lot easier. And then there's the x and y intercept technique. which again, we'll talk about both of those techniques later. But if you have no idea what to do for a graph, you make a table. Well, first you solve it for y, make a table, you pick numbers for x, plug them into the equation, solve them for y, and then plot the points. And then you just keep plotting until you know what the shape is. So let's try another one. Let's try number 54 in the book. Y equals x squared plus 1. And again, that square means it's not a linear. This is actually what's called a quadratic equation. And you would have to plot a whole bunch of points until you know what it looks like. Now this is a little overkill, this chart. I would stop. I would write this last column normally. And I probably wouldn't even do the middle one. So if I do 1 squared plus 1, 2. Do 2 squared plus 1 is 5. -1, -1 squared plus 1. -1 squared is 1, plus 1 is 2. -2 squared is 4, plus 1 is 5. Now, if you didn't know what the shape of this curve was, this is not enough points. So let me plot those 5 points. So we have zero, 1, 1, 2, 2, 4, 2, 5. -1, 2, -2, 5. Now, if you don't know what the shape is, that's not enough points. So you'd have to go back to your chart. I'll do the abbreviated version. Like if I put in 1/2, that's 1/4 plus 1, that would be 5/4. So I plot 1/2 and 5/4. And then if I did -1/2, that would give me 5/4. And again, this wouldn't be enough unless you had some knowledge about x squared. If you knew it was a parabola, you knew the shape, and you could draw it. But if you don't, you got to plot a whole bunch of points until you know the shape. Okay, so, and you have later in the course, of course, we're going to talk a lot about quadratic equations, parabolas, and you'll know everything you want to know about graphing parabolas later in the course. So you have that to look forward to. All right, so that's a basic introduction to graphing. This is your first technique, is just make a table, pick numbers for x, plug them in, figure out the y, plot the point. And you just keep doing that and keep plotting points until you know what the graph looks like. If it's a linear, you only need 2 points to determine a line, so I like to do 3, so the third point is the deck. All right, so that is it for 2.1.